Hi there, Mr. Sutton here, bringing you the Algebra 2 Honors 8-6 Part 1 homework solutions on permutations and combinations. For this problem, they want us to find the number of ways we can arrange all of the letters and then two of the letters in the given word. So let's do all the letters first. So when we just start off here, we have a choice of 3 letters. Next, we're going to multiply that by the number of choices for the remaining letters. So there's 2 left after we use that first one, times that one last letter. So that all comes out to 6. And then if I just want to use 2 of the letters, again I have 3 choices for that first option. There we go, 3 times 2 letters for that second option. And then we don't need any more letters, so that's just 6 that comes out to. For this problem, the number of ways I can arrange all of the letters in the word family, let's do that first. So we have 6 options for the first letter. After that, there's 5 for the next one, and I'll multiply by each of these. Then we have 4 left, then 3, then 2, and then there's that one last letter that we were just kind of stuck with. So I could probably use a calculator on this, but let me see if I can do this without a calculator. So 6 times 5 is 30, times 4 is 120, times 3 is 360, times 2 is 720. Boom. And then if I just want to use 2 of the letters, I've got 6 choices for the first option, and then there's 5 letters left over for that second letter. 6 times 5 is just 30. For this problem, we're doing a number of permutations with 9 items, picking a list length of 1. So you could do this using the formula n factorial over n minus r factorial. So in this case, 9 factorial over 9 minus 1 factorial. But if you just kind of think about this logically, this is one of our base cases. There's only, if you have 9 things to choose from and your list length is only 1, that means there's really only 9 different ways you could do that. Just pick a different one each time. So this should come out to 9. For this problem, we're doing 8p6, and we're allowed to use the factorial on the calculator. So let's use our formula. So we're going to have the n factorial, so 8 factorial in our numerator, over n minus r, so 8 minus 6 factorial in the denominator. And let me make a fraction and enter all that. So we have 8 over 8 minus 6. And that's factorials all around. That gives us, ooh, that's a lot, 20,160. In this problem, they want us to count the possible combinations of R letters chosen from the given list. So basically picking 3 letter sequences from A, B, C, and D. So we'll just write out all the permutations and cross off the ones that are repeats and count them up. Count up the ones that haven't been crossed off. This is absolutely the long way to do this. There's much shorter ways of doing this, but this just gives us a little practice with sample spaces. So we've got A, B, C, D, that's our ABC rather, that's the first combination that we can do. Then we can do A, B, D, and after that let me do A, C, B, and A, C, D, and after that I'll do A, D. So A, D, and then B, and then A, D, C. Next, I have to start with the B's. So let me do BAC, then BAD, and then I'll do BCA and BCD, and then finally BDA and BDC. Now I'll do all these starting with C. So CAB, CAD, and then let me do CBs now, so CBA and CBD. And then finally, we've got, let's see, what do I have to do next here? Yes, CDA and CDB. Finally, let me do the Ds. So DAB, DAC, DBA, doing business as, DBC, and then we've got DCA and DCB. All right, so that was fun. Now let's cross off the duplicates. So ABC, that's the first time encountering those letters, and ABD as well. Let's see, ACB, first time encountering those. ACD, haven't seen that combination before. And then we've got ADB. Well, we've seen that before up here. Oh, ACB actually was ABC, and then ADB, we saw that up here. so we'll cross that one off. ADC is the same as ACD, so cross that off. Next up, we're going to see a lot of duplicates now. BAC is the same as ABC. BAD is the same as ABD. And then BCA, that's the same as ABC. BCD, that is, let's see, do I have that already? I'm not sure that I do. No, I don't think I've seen this one before. All right, next up, let's do BDA. That's the same as ABD. And then BDC is the same as BCD, so those are the same. Let's keep going. CAB, we've seen the A, B, and C combination before. And then really another way you can think about this is letters you're leaving out, right? So this first one, we left out D. This next one, we left out C. This one, we left out B. And this last one, we left out A. So really, just think about it in terms of what we're leaving out. Here, we're leaving out B. We've already done that. We already left out D, left out A. Here, we left out B. Here, we left out A. We already left out C, left out B, left out C again, left out A, left out B, and left out A. That's way faster just thinking about it in terms of letters that you've left out. So how many did we come up with here? 1, 2, 3, 4. In this problem, we want all of the possible two-letter combinations of letters from this list here. There's 6 letters total. So let's go ahead and write out all the permutations and we'll cross off the duplicates. So first I've got U with all of these letters. So U, V, W, X, Y, and Z. Next I've got V with all of these. So VU, VW, X, Y, and Z. Next we have W with all of them. And that's a U, V, X, Y, Z with the W. And then XU and all the other letters with X. So V, W, Y, and Z. And finally, let's see, we've got Y with all the other letters. So YU, V, X, Y, and Z. And finally, Z with all the other letters. So ZU, V, W, X, and Y. All right, what are my duplicates? So my first column, all of these are unique. U is getting used with every single letter for the first time. In the next column, U has already been used with everything else, so this VU is gone. And then these are the V's with everything else that V has not been with before. So these are all unique. Next row, the U already got used. V's already been used with everything, but W hasn't. So here's all the W's being used with everything else. Then we have the next column. U, V, and W have already been used everywhere else, but we have X, Y, and XZ are unique. After that, U, V, W, and X have been used with everything. YZ is unique though. And in the last one, we've already used the other 5 letters every single time at some point with Z. If you look down here, all of these Z's, we already used them. So we're going to cross off everything in that last column. So counting up what's left, we have 5 plus 4 is 9, plus another 3 is 12, plus 2 is 14, plus another 1 is 15 combinations. On this one, we are going to evaluate this combination, and we're allowed to use our factorial on the calculator. So using our formula, we have n factorial, which in this case is going to be 8 factorial, over n minus r, so 8 minus 5 factorial, times, we want the r value, 5 factorial. And then let's plug all that in on Desmos. So fraction, 8 factorial, 8 minus 5 factorial, and then 5 factorial, gives us a grand total of 56 different combinations. For this problem, we're going to use the combination formula with factorials in order to evaluate this. So we've got 12 factorial, that's my n, over n minus r, so 12 minus 3 factorial, times the r, that's 3, factorial. Plugging all that in on the calculator, we've got 12 factorial in the numerator, 12 minus 3 factorial down there, and a 3 factorial. grand total of 220.